Hello students, today we'll see merge sort technique. Okay, so bubble sort is over, selection sort is over, of course insertion sort is also over. Every sorting technique has unique method in order to sort the elements. So in all these three cases we have chosen array itself. Okay, there are n array elements in unordered way, and finally they have been sorted. Okay, using the merge sort, how the sorting technique is going to be done. So this is a special kind of sorting technique and fastest sorting technique. So in which the merge sort follows the rule of divide and conquer. Means merge sort in which the divide and conquer method or the technique is used. So previously in binary search technique we have seen this divide and conquer method. So what do you mean by divide and conquer? So divide means a list is going to be divided into 2 or 3 or 4, whatever it may be. Okay, so generally a list is going to be divided into 2. Then the problem, whatever the problem is there, whatever the operation is there, that is going to be performed. Then again, so we'll say if it is further it is needed to divide it, so it will be divided again. So like that. So divide and conquer means suppose if n elements are there, n elements will be divided into n by 2, n by 2, like that. Okay, so one large list will be divided into 2 subparts. Okay, so merge sort follows the rule of divide and conquer method to sort the given set of numbers or elements recursively, hence consuming less time. So recursively means again and again. Okay, if you divide any list into 2 once, so probably you can't find the perfect solution for it. So you need to go on dividing the list. So until certain thing is what I can say enforced. For example, in this particular case, we are going to divide the list into 2 until you get single element. Okay, so this is nothing but dividing procedure. A list is going to be divided into 2 sublists until the particular list or list is reduced to single element. Okay, so the same thing has been enforced in the binary search also. Okay, next, this divide and conquer method, if we break a single big problem into smaller sub-problems, solve these smaller sub-problems and combine their solutions to find the solutions for the original big problem, it becomes easier to solve the whole problem. So the total the information in this particular paragraph, divide and conquer method, the intent of this one is, if a problem is big, say if a problem is big, or if any program is say large or a big program of say 100 or 1000 lines, probably it is difficult to debug, it is difficult to do a certain task, or it is difficult to execute or difficult to maintain. So what you are going to do is, this big problem is going to be divided into smaller. So what you can say, this is called modularity. So one big problem is going to be subdivided into more than one, say 4 or 5, whatever it may be, and each program or each small segment is checked or is solved. If we break a single big problem into smaller sub-problem, solve the smaller sub-problem, solve it. This is a single segment, isn't it? So just solve it, so on. After you obtain the solution or find the solution of this, combine their solutions, find the solution for the original big problem, it becomes easier to solve the whole problem. If you want to solve the problem as it is, if it is big, so then it is very difficult, very it is tedious to find the actual solution. So then only one thing is dividing the list, divide the problem. Similarly, if there is a large list of large elements are there in a particular list, we have to break that single big list. So replace this problem with list or array. Okay, sub problem, sub list. Okay, so all these problems will be replaced by list or array. So single array is going to be subdivided into multiple smaller lists, and we are going to do the same kind of job on smaller list. So once you found the solution for all individual, what you can say, small list, then we are going to combine the list. So if you combine all these things, then probably it is nothing but it is the solution for the original big problem. Okay, so this is nothing but divide and conquer method. A big or the complex problem is going to be subdivided into smaller lists or n smaller problems. The merge sort is going to work, or merge sort generally works on this method, divide and conquer method. In merge sort, given unsorted array with n elements is divided into n subarrays, not once, not at a time. Okay, each having one element, because a single element is always sorted. Means once this large or unsorted array is divided into n subarrays, and finally small subarray will have single elements. This is L1, this is L2, this is L3. Each list or n number of lists will have single element. When it reaches to single element, then we will apply the next measures. Okay, it repeatedly merges these subarrays to produce new sorted subarrays. So when each list has limited to single element, okay, then we will start sorting the elements. Okay, so we will compare the element of list 1 with list 2, then we will combine, then list 2 with again combine things like that. Okay, so it repeatedly merges these subarrays to produce new sorted subarrays, and in the end one complete sorted array is produced. Means very first you are going to you are going to divide the list into different lists. So until the list reaches to, until the list will have single element. So once the list will have single element, we'll stop dividing dividing procedure. Then we are going to solve the problem, whatever it may be. It may be comparison, it may be compare and interchange, whatever it may be. Then we are going to merge things. Then we will merge. Merging is nothing but it is the opposite work of dividing. So then we will go on merging, single into 2, 2 into 4, 4 like that, and finally we will obtain the sorted merge list. Okay, so the concept of divide and conquer involves mainly 3 steps. First one is divide, means divide the problem or divide the list. Divide the list into multiple small problems or multiple lists. Conquer the sub problems, means what is your intention, what you want to do actually on the list, on the big list. Big list ಮೇಲೆ ನೀವು ಏನು ಮಾಡೋರಿದ್ರಿ, whether it is you are going to search or sort, whatever it may be. So ಈಗ ಇಲ್ಲಿ sort ಇದೆ, so you go on sorting for the upon the smaller one. Conquer the sub problems by solving them. Here what you are going to do is you are compare and sort. The idea is to break down the problem into atomic subproblems where they are actually solved. Okay, so divide the larger list into smaller one and conquer them. So once you get the intermediate results, you combine all this. Suppose if you have two sorted elements, you insert this one, sorted one, whatever it may be. So increase the number of elements like that. Okay, so go on combining the sorted elements. Combine the solution of the subproblems to find the solution of the actual problem. Divide it, conquer it, and finally combine it. So after you combine all the elements, so you will find the complete sorted elements. Okay, so here there is a diagrammatic or pictorial representation of a big problem. So this big problem is divided into two subproblems. Okay, this subproblem may be again divided into some more problems. So this is to just give the significance or the sign of a problem is going to be divided into subproblems. Okay, this subproblem may be again divided into some subproblems. Okay, so once it is a subproblem, then conquer it. Here conquer it. Solution to subproblem. Find the solution to this subproblem. Say sublist S1 and say S2. So problem or solution is found for this. Solution is found separately. Find the solution to smaller or sub list or sub problems separately, independently, individually. Then yes, problem is solved. Then combine the solution. Here also solved, it is sorted. Say here also it is sorted. Yes, if two sublists are sorted, say it is unsorted. Here there are some elements unsorted. Okay, by dividing these two, this particular list into two, and suppose 4 or something, you will find the solution, and finally you have two lists sorted. This is first list and this is second list. In this list sorted elements are there. In this list, list 1, sorted elements are there. So what you are going to do is you have to combine this. It is also sorted, it is also sorted. So combine the elements here. Combine them. So while combining, again you may go for comparison. Okay, so you may go for the comparison. Okay, so that once you combine it, you will find the final solution. Means all elements will be sorted. Okay, so in front of us, so there is a small example. Okay, where there are some array elements. So it is first element 0, 1, say 2, 3, it is 4, 5, 6, 7. Means there are 8 elements. In some cases there may be 9 elements or 7 elements. So it is not necessary that even number of elements should be there for merge sort. The merge sort works on unsorted list with n elements. That n value may be even or odd. Okay, so here even number of elements have been taken. So this one is middle. Yes, this one is middle element. Say if you want to divide this particular array, so 4 elements here, okay, and 4 elements here, isn't it? 4 elements here and another 4 elements here. Say 4 elements and here 4 elements. Next, this is list 1, isn't it? This is list 1. This is list 2. Then 27, 12, 15 and 47. These 4 elements will become the first. So this is nothing but division, divide 1, first level of division. And similarly here 35, 67, 55 and 45. So this particular list, original list, is divided into two lists. In some cases, here may be 4 elements, here may be 5 elements. So it is not compulsory that both should have equal number of elements. So depends upon whether the number of elements means n value is even or odd. If it is even, then equal will be there. If it is odd, if n value is odd, then any one list will have one more element. Okay. So next, this first divide. So with the first division or divide, so you will find 27, 12, 15, 47 in the first list, 35, 67, 55 and 45 in the second. So in the divide and conquer, so we will go with another division. So here, this is middle, isn't it? This is middle. So this is sub 1, this is sub. So 27 and 12 is another sub list. 15 and 47 is another list. So this is one list and this is another list. Okay. Next, similar here, 35 is one list, 36 is one list, and 55 and 45 is another. So from 8, once again, from 8 elements, 4 elements will be there. From 4, 2 elements. Okay, divided into 2 elements. And in the divide 3, in the third level of division, so 27 and 12. So where there are 2 elements in a list, so again it is divided into 2. So this is list 1 and this is list 2. Now in this case, single element, the list is reduced to single element. This is L1, this is L2 of course, this is L3 and this is L4 of course, this is L5, L7 and L8. There will be 8 lists. There will be 8 lists, or here there are 8 lists. In this particular example, 8 lists. Each list, like list 1, list 2, list 3, 4, has single element. So when all lists are reduced to single element, now you have to stop dividing. Now you have to stop dividing the list. So what is the next method? Next is conquer. Conquer means find the solution for it. So what is the solution for us? So here, so what you need to do is, so you have to compare this. You have to compare this 27 and 12. You have to compare 27 and 12. So in this 27 and 12, so 2 lists, you are going to compare 2 lists, list 1 and list 2. Here 27 is greater than 12 or is less than 27. So 12 should come here and 27 should here. So compare and merge. So list 1 and list 2 become one list. So after interchanging the values. Similarly 15 and 47 you going to compare and it is sorted only. So directly merge 15 here and 47 here. Next, comparison between 35 and 67 is L5 and L6. So because the 35 is already less than 67, so directly it will merge to produce another list. So 35, 67. And next is 55 and 45. This is list 7 and list 8, I think. Yes. List 7 is 55 and list 8 is 45. But 45 and 55. So 45 should come first and 55 should go there and these two should be merged. So this is merge 1. Means merge level 1. M1. So from here it is dividing. So here from here, so merging procedure will start with the first level of merging. So we find 12, 27 with one list, 15, 47 in second list, 35, 67 in third list, and 45, 55 in fourth list. So from 8 lists, we now obtained 4 sorted list. This is list, sorted list, and it is second list, it is third sorted list, it is fourth sorted list. This is first sorted list has 2 elements, second sorted list has 2 elements, again third sorted list has 2 elements, and fourth has 2 elements. Okay, fine. Next, in merge 2, second level of merging. So this is list 1 and list 2. So these two lists, how these two be merged? Here first element and first element. Consider the first element. So here is 12 and it is 15. So because 12 is less than that, so 12 will be here. Next 27 and 47 compared. 27 will come here, 47 will come here. So from 2 lists we obtained one list. Isn't it? Similarly, list 3 and list 4 elements are merged again. While merging we compare the elements, of course. So how we are going to compare? 35 will be 45, means first element. So 35 is less than 45. So 35 come first, then 45. 35 and 45. Next 67 and 55. So 67 is greater than 55. So 55 will occupy first place than our previous of 67. So now the list become 2 lists, means 12, 15, 27, 47. 35, 45, 55, 67. So last step is merge level 3. Here 12 and 35 is going to be compared. 12 and 35 will compare. So that is less than 35. First sorted is 12 only. Then 15 and 35 will be compared. Okay, 15 and 35 will be compared. 15 is less than 35. Okay, 15. So 12, 15 means 2 elements from the list 1 only. Next 27 and 35. 27 and 35 will be compared. So as 27 is lesser than 35, 27 will come here. Next 46 47 and 35 will compare. As 35 is less than 47, so 35 will come here. Next, this 40 will compare with 45, because the 45 means second element of second list is smaller than this one, so 45 will here, 47 is here only. Then 47 and 55 is compared. As 47 is less than 55, so 47 will occupy. Then think that all elements from the first list have been placed here, but still 2 elements are here. So here we need not compare 55, 67, it is already combined and merged. So if any one list is exhausted, directly place the remaining elements. Okay, directly 55 will come and 67. So see, this is the sorted list. Okay, so once again I will show the same thing. Okay, these are sorted, okay, at the initial, but once you divide this one, we'll have 4 elements, and here 4 elements from 35 to this one. Here 4 elements. So here 4 elements. Okay, next these 4 elements are again divided into 2 elements each. Again here 35, 67 will be in one list, 55 and 45 will be in another list. Then 27 and 12 will be again divided, so that 27 is separate, 15 is separate, 14 is separate, here 35 is separate, 67 is separate, 55 is separate, and 45 is separate. So with this particular level, divide procedure is closed, or it is completed. Why? You should stop dividing here. Why? Because all lists in this particular level have reached to single element, or all 8 lists will have only one element. So when it is reached to single element, we should stop. So we cannot divide it. So next stage is to compare. So this is list 2. List 1 and list 2 will be compared. Okay, so comparing, is going to be less than this one, so 12 will come first, 27 will. Next, for this particular 12 and 27, you will compare 15. 12, 27 and 15 list, and this is second list. So 15 will compare with 2, okay, and 15 will merge it again. So how it will be? Sorry, 15 and 47 is separated. 15 and 47 will compare, and 15 and 47 will be arranged as it is. Similarly here, 67 will be arranged as it is. Okay, list 1, list 2. Here 55, 45 is that list 7 is 57, 5, list 8 is 45. So 45 is greater than 55. So 45 will come earlier than 55 and merge. Okay, now from 8 list to 4 list, this is merge 1, M1 is M1. Okay, next two elements are there in each list. Again, these two lists will be compared. Elements are compared and merged. So that 12, 15 and 15 is compared, 12 is obtained. 27 and 15 is compared, 15 is here. 27 and 47 is compared, 27 will come here. Next, only one element is there, 47. Similarly here, first 35 and 45 will be compared, 35 will come here. 67 and 45 is compared, 45 will be here. 67 and 5 compared, 55 will be here. And only one element is there, so that we will put here. Next, list is merged and reduced to 2 lists. Each list has 4 elements. This was sorted list, of course. This was sorted list. 12 and 35 is compared, 12 will be here. 15, 35, 15. 27 and 31, 27. 47, 35, so 35 will here. 47, 45 will here. 47, 55 will compare. 47 will here. So when 45 is taken from here to here, now this is exhausted. Means there is no element to compare much. So only 2 elements will be remaining. 55 and 67. So these will be directly. So this is nothing but a merge sort. Okay, this is nothing but a merge sort. Okay. So I hope you have understood this one. So try once.